the module 2 easy questions, starting with the first one, that is what are sensors and actuators. So what are sensors? Sensors are some things that sense. These are objects that sense, where it measures a physical quantity and converts the measurement to a digital representation. So what happens is it gets the data, it transforms the data, and then it uses the data in the required format. There are mainly 7 types of classification of sensors, that is active, passive, invasive, non-invasive, contact, non-contact, absolute or relative. It depends on area of application, how the sensors measure, and the 7th one being what they measure. In active or passive, if an external power supply is there, it is called an active. Or else, if there is no external power supply, then it's a passive sensor. So you have invasive, non-invasive. Invasive is if it is part of the environment, then it is invasive. If it is not part of the environment, it's non-invasive. Contact, non-contact. Physical contact is if it has physical contact being provoked, then it's a yes. If it's a yes, then it's contact. If it is a no, then it is non-contact. Then you have absolute and relative. Absolute scale is you have fixed set of values which you always refer to. And then you have relative values that uses variable references. Like for example, if you keep the highest temperature ever recorded, you need to use a variable temperature. So whenever there is the highest temperature which is present, your new value becomes you have to compare with the new highest temperature if you keep crossing the highest temperature. Then you have area of application, that is it is specific to industries where they are used, the area of application, that is. Then you see how the sensors measure. It is either physical or it's easily physically done or sensory, that is either optic, electric, thermoelectric. And then what they measure, the application of physical or application variables. So you see what they measure. If they measure heat, they measure light. If they measure something else. So then you have actuators. These are the ones that take action. These get the actuators these are devices that get control signals and triggers a physical effect. So what happens is you have real world, that is your physical environment, and then in which the sensors are placed, and then these sense the things, and then they send the measurements to digital representation of electrical signals. These electrical signals are triggered, and then these are the this is the actuators function. The actuators act, and then they make the work useful. So they make sure that there is a physical action being done. Actuators are classified into 5 types. That is a type of motion, either linear or rotatory. Power, that is high power, low power, or micro power, which is required. Binary or continuous, that is your stable state outputs. Either you have zeros or ones, or you have 0, 0.1, 0.2 increasing values. And then you have area of application, either an industry or where they're applied. Type of energies. So what happens? Actuators are defined on the type of energy, the energy type. So they're mainly classified based on the energy type. Mechanical energy, you use screws, levers, or jacks. Electrical energy, these are diodes, bipolar diodes, transistors. And then you have electromechanical, that is your AC motor, DC motor, your step motor. Then you have electromagnetic. You have your electromagnetic linear solenoid. And then you have hydraulic and pneumatic energy type. Here it is your hydraulic cylinders, your piston, your pneumatic cylinders. Then you have smart material. These are related to temperature and magnetic force. This is your bimetallic, your piezoelectric, bimajor. And then you have your micro and nano, that is your electrostatic motors, your micro valve, and then your comb drivers. So sensors sense and give the information. Actuators take action. They take action. And then give an example of how sensors and actuators work. For example, on reaching a high temperature, an alarm gets triggered, and then alerts the information, a smoke detector, for example. What are smart objects? Smart objects are They're like IoT building blocks. What happens here is you have an intelligent object that is able to learn from a given set of training data, and then can interact with the government, and can interact with the environment in a meaningful way. What you're doing is you should be able the ability to this is the ability to communicate over a network that has multiplicative effects and allows a very sophisticated correlation interaction between disparate smart objects. So what you're doing is here is you're not only sensing the object, you sense it and then make sure you take action. So you're taking an action to make sure that you're finding a solution for it instead of just detecting whatever is happening. So what you're doing this is you using the coordination of sensors and actuators set so that they're intelligently interconnected with each other to coordinate fertilization. To coordinate the event to make sure it is a complete success by not only triggering it but also automating the response. The exact definition of smart objects is a term of the term smart object, despite of some semantic differences, is often interchangeably with terms such as smart sensors or smart devices or IoT devices or intelligent devices. A smart object is described as a device that has minimum one of the following four characteristics. It either has a processing unit or a sensor and actuators or communication device or power source. Okay, what happens in a processing unit is a smart object that has some type of processing unit acquires the data, processes and analyzes the data, sensed and received from the sensors. This coordinates control signal and then it initiates a action to be taken by having a communication and power system. Most of these is a microcontroller because it's a small form. It is small form factor, flexible programming, simplicity, and low power consumption and low cost. Sensors and actuators. A smart object is capable of interacting with the physical world through sensors and actuators. A smart object does not need both sensors and actuators, but in fact, a smart object contains one or multiple sensors and actuators depending on its main application. Then you have communication devices. Now it should be able to work via a network because you're trying to communicate from a sensor to an actuator. So what you're trying to do is you have in an IoT network, smart objects are wirelessly interconnected for a number of reasons, including cost, limited infrastructure availability, and ease of deployment. Then you have power source. The smart objects need to be powered so that they can continuously work and communicate unit and power consumption usually happens in the communication unit of a smart device. These are limited in power and they are deployed for a very long time. So it must be power efficient and judicious power management must be done using sleep modes and ultra low power consumption and low power consumption hardware and so on by using critical design elements. For long term, you either use battery powered or they are done through supplying electricity or current to it. The trends in smart objects. Okay, so what you have is you have a tiny computer that is embedded into objects that make them smart. Okay, you have a low cost computer, tiny low cost computer. You have a sensor that senses the physical data, actuator that is capable of performing tasks, and then communication device that receives instructions and sends the router the data that has to be sent. So what happens here is we know that smart objects can vary in their functions, but these are the most common trends. So size is decreasing. The main trend is size is decreasing. Now we started with the large mainframe computers, and then we have come to a state where we have everything which is performable at the palm of our hand and on the wrist of our hand. So what happens here is, earlier you have to write that in words. It tends to every decreasing size. So the smaller the object, they are not even visible to the naked eye. This reduces the smart objects, is easy to embed into everyday objects. Then you have power consumption decreases. Different hardware components, they continuously consume less power. So this is true for sensors which are passive. Some battery powered sensors lasts for 10 or more years without battery replacement. So then we have processing power increases. You need smaller size, uh, low power consumption, and processing power to be increased. So what you're doing here is the processors are continuously getting more powerful and smaller. This is the key advancement of smart objects as they become increasingly complex and connected. The communication capabilities are improving. Communication capabilities are improving. So what you're doing is you're trying to increase the range by making it better for communication, and then specialized in communication protocol by covering a great diversity of use cases and environment. Communication is being increasingly standardized. Here, there is a strong push in the industry to develop an open standard for IoT communication. So, in addition, there are more and more open source efforts to advanced IoT. These trends in smart objects begin to paint a picture of increasingly sophisticated devices that are able to perform increasingly complex tasks. Communication is being increasingly standardized. So the power of IoT truly is unlocked when the smart objects and are networked together with sensors and actuators network. So we have done two of the easy questions now. That is your sensors and actuators is done, and then your smart objects are done. So in the pending we have wireless sensor networks, SANET, with advantages and disadvantages, and types of sensors. So this is also been covered. Types of sensors, which are your active or passive, invasive, non-invasive, contact, non-contact ones. So this is also done. So we have 1 and 2 left in the easy questions. So what are the sensors network? Sensors and actuators network is called as SANnet. Okay. Then, as the name suggests, it's a network of sensors that sense and the measurement and measure their environment, and or the actuators that act on their environment. So the sensors and actuators in a SANET are capable of communicating and cooperating in a productive manner. So what you're doing is you're trying to communicate with sensors and actuators and make sure that it is productive, and the work gets done. The efficiency and well coordinated communication and cooperation is a prominent challenge. So you need to make sure that it is well coordinated and communication happens properly. SANETs offer highly coordinated sensing and actuating capabilities. So in smart homes, there are SANETs that display coordination between distributed sensors and actuators. So you have strategically networked with heating. So you have temperature sensors that are networked with heating, ventilation, and air conditioning. That's HAVAC actuators. So the sensor detects a specified temperature that this then triggers and then heats or cools the home as needed. So while such networks can theoretically be connected in a wire or wireless fashion, the fact that SANETs are typically found in real world means that they need an extreme level of deployment flexibility. For example, smart home temperature sensors need to be expertly located in a strategic location in their house. So what you're doing is here you're theoretically connecting it with through wired or wireless. But you're just making sure that it is the level of deployment is extremely flexible. Here the advantages are as follows. Okay, in a wireless based solution offers. So what you're doing here is great deployment flexibility. So you can put them in any environment or hard to reach places because it's wireless. and then simpler scaling to large number of nodes. So instead of having so if you have 10 nodes, you have to connect 10 different wires to 10 nodes. Instead of this, having a wireless solution gives you easier this thing. So you have low implementation cost, wire cost is saved, and then it's easier on a long-term maintenance. Now you don't have to you don't have to bother about your wires getting cut, not being long enough, having to frequently change them. And then you have effortless introduction of new sensors or actuators. You can add any new sensors or actuators and then connect it directly to the wireless instead of having them to rewire. Now, if this is in one area and then that is in another area, all this will be connected through one wire. And for this, might have to pull a separate wire. So that is why it is easier to introduce in a wireless. So it is better equipped to handle dynamic or rapid topology changes. So you can have star or mesh topology easily than a normal wired system. Your disadvantages are only three. That is your potentially less secure because since it's connected to the network and it can be hijacked via access points. So they are typically low transmission speeds. So you have lower transmission speed and greater level of impact by the environment. Greater level of impact by the or influence by the environment. Like if you don't have a power supply, then your wireless gets interrupted. Then it depends on how your area receives network. All these comes under the disadvantages. So you have 3 disadvantages and 6 advantages. So the last part of these easy questions is wireless sensor networks. So wireless sensor network, what happens over here is wireless sensor network is made up of wirelessly connected smart objects. In the previous ones, what happened is you either had a wire or wireless connection. Here you're making sure that all the sensors are wireless, in which these are referred to as modes. It's also sometimes referred to as modes. Okay. The fact that there is no infrastructure with the WNS is surely a power advantage for flexible deployment. Since you don't have any wires to bother about, it's a flexible deployment. But there are various constraints also in having a wirelessly connected smart objects. So what you do here is you have a similar structure when compared to a SANET. Here what happens is you have a moderate CPU power which optimizes minimum energy. Then you have a low memory that can hold only a little bit of memory. You have lousy communication that is powered by wireless mesh, and then you have a narrow band media. Then you have power consumption is critical. You don't have to. The difference between smart SANET and WSN is that it is low cost tiny computer. Here it is moderate power consumption. Here you have a sensor. Instead of that, you have low memory over here. You're labeling this as low memory. It's the same diagram. And then what you're doing here is you know that it's a lousy communication. This communication device is a lousy communication. And then you have a narrow band media that it can only cover up to a few distance. You don't have a lot of area which can get covered. And then you have this part is called as power consumption is critical. That is, your energy is efficient and is paramount. So if it's a battery operated device, it may last years. I mean, it depends on how much capacity it can hold. So what you have to do is you need to find out the most significant limitations of smart objects. So what you're doing is limited processing power. So since you can't process a lot of things, you have a small device through which you have to communicate through far off distances. So you have limited processing power, limited memory because it's a small device where everything is contained. It has lousy communication because it cannot cover a lot of distance. It has a range which can be fulfilled. And then transmission speed. Since you're using it to connect without wires, what happens is your transmission speed reduces and you have limited power which can be used. So what happens is that these influence on how the wireless sensor networks are designed and deployed and utilized. So what you're doing is your individual sensor networks are limited. You have a lot of limitations, right? So what you're doing is the cost of the nodes continue to decline because the ability to deploy higher redundant sensors become increasingly feasible. So now what you're doing is you have a lot of you can use multiple, since you're cutting costs on wires and other things. So what you can do is you can deploy a better sensors and then make it feasible. So these sensors may be very inexpensive and inaccurate. So if you're using cheaper quality, sometimes what happens is it becomes inaccurate, right? So you use so the ability to deploy smart objects redundantly allows you to increase accuracy. So if you're sending the same data again and again, you can increase the accuracy. Such number of sensors permit the introduction of hierarchies of smart objects. So what you're doing here is you're aggregating the similar sensors and then finding the readings close to each other. So what you're doing, for example, here is you find a wireless sensor network. Okay, so this is the temperature detection in the drawing room. This is the temperature detection in the kitchen. This is the temperature detection in the bedroom. This is the temperature detection in the master bedroom. This is the temperature detection in the dining room. This is the temperature detection in the storage room. Okay, so what you're doing is to find the what you do here is you aggregate the data and then give one temperature as your data which is being used redundantly. So what you're doing here is you take the average. It may vary in each the temperature of each room may vary, but what happens here is you're getting an average temperature. So this is being sent to the network, and the action from the actuators are being taken on this the average temperature. So by instead of sending every room's temperature, what you're doing is you're reducing the amount of data which is being deployed, since it has a smaller storage area, and then the fog and mist computing are helpful. So in certain instances where the sensors are continuously streaming for this data, this is not the case. Wirelessly connected smart objects generally have communication pattern. It's either event driven or periodic. Event driven is only it is triggered only when the smart object detects a particular event. So if it goes below this temperature or above this temperature, that is when it gets detected. And then periodic is the transmission of sensory information only at periodic intervals. So after every 20 minutes you send an information. That is periodic transmission. So the decision of this communication schemes are usually specifically done. So in medical cases, the sensors are periodically and post preventive vitals for such things like body temperature, blood pressure. The readings are taken.